This is Pre-Calculus 12, Chapter 8.2. We're going to be looking at permutations of different objects. And to permute means to arrange. Permutation is to find all different ways to arrange objects. So order is important. This is a slight variation on fundamental counting principle. We are arranging objects that are not identical. How many ways can hat be arranged? Well, hat, all different letters. That means we are arranging objects that are not identical. So let's just start off with hat. And the best way is to keep the first letter until you've rearranged all the letters after that. So we're going to rearrange TA. Then we're going to use our second letter as our first letter and then rearrange the next two letters, ATH. And then we use our last letter, T. And then we rearrange the remaining letters, HA, TAH. And that's all there is. There's no more. So there's 6 ways. But let's look at the pattern. There's 3 ways to choose first letter. Once we've chosen our first letter, there's only 2 ways to pick our second letter. Okay, because the second letter is dependent on the first letter. And then we only have one choice for third letter. Only 2 ways for second. Okay, and when you have one choice, that's really no choice. And using a chart, is okay for small sample spaces. Okay, and not good for large. Okay, we saw that with the meal combos in the last section, and the tree got very large. And if you use this permutation method, it also gets fairly large if you have a lot of choices. So use it for small, and then we try to generalize for larger problems. We can generalize for any n objects that the number of arrangements is n times n minus 1 times n minus 2, all the way down to 3, 2, 1. And there's a function for this operation, and it's called factorial. And the notation is n exclamation mark. And by definition, we have 0 factorial equals 1. If 0 factorial was 0, we would be in trouble, but this problem doesn't come up until later. So for now, take my word, 0 factorial is best if we define it to be 1. How many ways can lucky be arranged? All letters are different. Okay, so we can enter 5 factorial on our calculator, so let's do that. So 5 factorial, we go 5, we go math, and then we scroll over to probability. And then we just enter 4, or you can scroll down to 4, and then press enter, and we get 120. So 5 factorial equals 5 times 4 times 3 times 2 times 1, and that's 120. So we're choosing this one. On the Casio, enter 5, we enter options, we press F6, and we go to probability, that's F3, and then we press F1 and execute, and we get 120. So it's not difficult on either calculator to do this. Okay, a lot of problems. We don't pick all the objects from the set. So if only R objects is to be selected from a set of n, then the formula is n times n minus 1, n minus 2, dot, 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 n minus r plus 2, and n minus r plus 1. And this is very cumbersome, so the way we say that is n permute r. And this is n factorial over n minus r factorial. N must be greater than or equal to r. If r is larger, it's undefined. It's an error. So let's look at an example. How many ways can object be arranged when choosing 3 letters? All different letters. Okay, so there's 1, 2, 3, 4, 5, 6 letters, and we're picking 3 of them. So this is 6 factorial over 6 minus 3 factorial. So this is 6 factorial over 3 factorial. And let's write this out. When we're doing a permutation of a smaller set, lots of numbers cancel out. This makes it easy to do this in our head. 5 times 4 is 20. 20 times 6 is 120. So let's look at our calculators. So 6, we enter 6. We go into math. We scroll over to probability. We pick number 2. And then we say 3. And we get 120. On the Casio, 6, options, F6, F3 for probability, F2 for the permute, and 3. And we get 120. There are 9 teams in the Western Conference of MLS, Major League Soccer. How many ways can the playoff standings be arranged if 5 teams make the playoffs? And that's no longer the case anymore. I believe there's 6 teams making the playoffs. However, let's continue with the problem. So we have 9 in our set, and we're permuting 5 of them. So this is 9 factorial over 9 minus 5 factorial. So this is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1, and they cancel out. This is a lot harder to do in our heads, even if we tried to find shortcuts. So we use the calculator. You go n, permute 5, and you get 15120. Okay, and you can do the same thing on the Casio. There are 12 horses in a race. How many ways can they finish first, second, and third? Win, place, show. Okay, each horse is different. Okay, so not all the horses are the same. They all have different names. And order is important. Remember, permuting means order. And because we're determining first, second, and third, order is important. So it makes a difference which horse comes first. So this is 12, permute 3. We have 12 factorial over 12 minus 3 factorial. This is 12 factorial over 9 factorial. And we got 12 times 11 times 10. And this is easy to do in our heads. 12 times 11 is 132. So this is 1320. And in case you don't believe me, let's do this on the calculator. 12 permute 3, 1320. Arrangements of arrangements. This is harder. So sometimes you need to keep some items together. So let's look at an example. 4 families are sitting in a row of seats. The families have 5, 4, 3, and 4 members each. Each family needs to sit together. How many arrangements are there? So we have to break this down. The 4 families can be arranged four factorial ways. Okay, because the families must sit together, so we have to treat the families separate. Now each family can be arranged so the first one is 5 factorial. That's 120 ways. Second family is 4 factorial, and we already know that's 24 ways. And we have 3 factorial. That's 6 ways. And we have 4 factorial again, and that's 24 ways. So now we can use the fundamental counting principle for the total count, because each of these are independent of each other. The way the first family sits has no impact on the way the second family sits, or any impact on the way the third or fourth or the families together. And if I've done my arithmetic correctly, we have 9,953,280 ways. Bring up the Casio. 24 times 120 times 24 times 6 times 24. And the answer matches. So note, if the families didn't have to sit together, we have 5 plus 4 plus 3 plus 4. This is 16 people. If we permute 16 people, we get 2.09 times 10 to the 13 ways, which is a far larger number. Okay, this is only 9.9 times 10 to the power of 6. So we're adding at least 6 zeros to this answer. So it's 1,000,000 times bigger. Let's look at some backwards problems. Solve for n. So we have n times n minus 1, n minus 2. This equals 210. You can enter this on your calculator, but you should always think about ways to be able to do this in our head. What kind of factors can we get? Well, we can get a 2. We add up the digits. We can get a 3. It ends in 0. We can get a 5. 21. We can divide this by 7. Can we divide it by 8? Question mark. If we divide this by 2, We get 105. That's odd. Because it's odd, we can't divide it by 2 anymore. So our largest factor is 7. So we must have 7 times 6 times 5 equals 210. Well, we'll verify by hand. 6 times 5 is 30. 7 times 30 is 210. So n equals 7. And if you try this on the calculator, 7 pick 3. 7 pick 3. We get 210. So there are ways of trying to figure this out without a calculator, but if you're really stuck, go ahead and do it. So you'll have to do trial and error. You might try 10 first. 720. This is bigger than our value here. So you need to try something lower. Then you might go to 5. 60. That's too low. So then you might go to 8. 336. Too high. And then you would try 7 or 6. But if you're going to use trial and error on a test, show these steps so you don't lose marks. Don't just put n equals 7. Show that you've been doing some work. Now for the harder problem. Most of you will just use guess and test. But if we look at this, what's an easy power to do? 10. There's 5 digits here. So 10 to the power of 4 is 10,000, which is 5 digits. So if we were going to guess, I would guess with 4 first. 3 might be too small, but let's go ahead and do this. So 4 is a good guess. So 13 pick 4. 13 pick 4 is the exact number we're looking for. And that completes this lesson.